So I'm excited. We will have a chance to roll out our solution activities and our solution, our module solutions, especially when we start with project initiation, requirements engineering, prototype demos, and uh, component integration. Right? I use the word parts because it's shorter, but it appears in a. You can display it, and then the solution demo. One of the things we wanted to call your attention to are the assignments that are in play. If you have not yet enrolled in EDX and uploaded your screenshot of enrollment, please finish that. I'm recording that for people who are joining us in progress since AdDrop cleared at the end of last week. Also due 3 p.m. I can roll this back if you haven't posted a screenshot of your textbook. We wanted to give people, and then this is an option. So posting proof that you have rented or purchased an electronic copy or low-cost rental or something is an option. However, I want to be very clear in stating that the textbook is required for the course, and it's really important to engage the one low-cost one, because this is something we just discovered. This textbook is offered free now as a part of open source. And so if you click here, it takes you to the location where you can download the PDF of Engineering Software as a Service. And you see links and references to SaaS, that's Software as a Service. And that's one of the cloud platform concepts that we likely covered something about. So there's platform as a service, software as a service, or application as a service. Here, and then there's infrastructure as a service, where all you get is the raw hardware. Software as a service, it assumes that you have the hardware, you have the platform, and you have the operating system already in place. And all you're doing is creating the software in that context. So the other pieces of enterprise development are irrelevant, not really irrelevant, but less of a critical constraint. And so that's one aspect of the UC Berkeley Dynamic Duo preference. This particular course and its textbook was cited by the IEEE, the IEEE, the International and the Association for Computing Machinery, as an exemplar of a course designed around software as a service. Yes. Has anyone seen this screen before?
Yeah, I saw it.
Okay. What we're going to
I
do,
have as well.
okay, I'm glad to hear that. Let me fix this link just so we're sure we can. I think the link only goes to there, and I had the whole line highlighted, which might be why it didn't display. Right? So the second one is significant because it provides some of the history and a good bit about legacy software engineering development models that teams use to work together. This one is more of we're going to show you how to do this as a team online in the cloud, utilizing software as a service, and we'll do it with Ruby on Rails. So that's significant because as you engage this and get into here, with this version of the textbook, one of the things that I'd like to stress to you, if you form a team and you would like to work through the development of an integrated enterprise solution just by following through the textbook and using Ruby on Rails and the resources for EDX, I would adjust the deliverables so that you could work this as a trial. I have offered this previously in the course, the last time I taught it, and that was in the summer of 2020, and then in the fall of 2019, and then they switched the schedule. So it's been a while, it's been 2-3 years. But this textbook, again, was cited by the Association of Computing Machinery, a division of the International Electrical and Electronic Engineers, IEEE, the folks who helped found the internet and develop the whole discipline of computer science and computer engineering. So the fact that subject matter experts worldwide have identified this course and this content in particular as an exemplar is no small matter. I've come close to teams adopting it, and then they go, oh, I don't, it would be nice to use like a cutting edge method to work as a team. And I'd like to learn about Ruby on Rails, right? So I want to learn more about that. But I'm just going to do what I learned in Java, right? And there's nothing wrong with that. But I am really strongly advocating that you take a closer look at this between now and the time we form up teams and ask yourself if this wouldn't be one of the coolest things to learn in this course. What am I saying? You can say that you developed an integrated enterprise solution in software engineering using the courseware and materials from UC Berkeley, MIT, and Stanford. And then you can point to this and people will go, wow, because it's that big a deal. And now it's open source. You don't even have to pay for it. The other book is a good reference, and it's useful to have and retain, and it's lower in cost. So the cost went down, and they rolled out a second edition. And if I didn't play that up enough in our previous class, please tell me that you're aware of this now. Okay? Are there any questions about the expectations for our second assignment here? So the second assignment would be all about, I'm in the wrong module. Sorry. Let me get back in the right module. There we go. Everybody with me?
Yes.
Okay. In case you had not seen it, both the textbook option and the license registration, this is a verbatim step-by-step that you walk through. I think we covered that in the previous class, right? So I do need that. I can extend to 11:59 p.m. tonight. So I can bump this back so it's just Tuesday. Is there anybody that might need until Thursday to finish getting your license registrations, your activation codes in and your textbook in?
I've done so already.
Okay. How many of you are familiar with the article summary?
I am.
Okay, so this one's due by the end of Saturday, which means you have until 11:59 Saturday, this Saturday, to do a short summary of an online article or peer-reviewed journal submission. And essentially, it's a much simpler format. And so as long as you read this, there is a quick example of what we did previously. the goal is to get a decent article on software engineering, because this is what our course is about. And what I'd like you to do is to try to identify a topic within software engineering that you find interesting. Maybe it could be development of multiplayer networked gaming solutions, or maybe it's it's the development in the Android environment. I don't really care. What you want to do is find something that's interesting to you. It's a much simpler criteria, and it's not intended for anybody to get bogged down in. There's just 2 paragraphs, and essentially you want to have a qualified article, meaning it's about software engineering. It needs to be written in proper English. 2 paragraphs. The first paragraph is about the article itself, the content of the article. The second paragraph is why others should take the time to read it, why you're interested in reading it, just like we had before. You have a title at the top and you have a reference at the bottom, and that's it. So those criteria are each worth a half a point. Title and reference, 2 paragraphs, proper English, the fact that it has something to do with software engineering, right? So we want to make quick work of this and just get it done. Now, each of you are enrolled in the senior seminar also, correct?
Correct.
All right, so
Yeah.
so this is an assignment that could also be leveraged when you get into the senior seminar environment and you're interested in reviewing latest developments in computer science, right? Now, about the solution. The solution is going to be posted after our class today, and I will expect it to be due next Tuesday by the start of our Tuesday class a week from today. What you're going to do is stand up and log into your own server so that you have a platform. I may postpone that solution to the end of module 2 because most of our hands-on comes from the project side of this course, from modules 4 through 8. So, I mean, we can't go light and we can skip a solution in the 3 early modules. But by the time you finish with modules 1, 2, and 3, you're going to want to have access to your development platform online. So gone are the days that you have to work all of this on your own machine, okay? Any questions before we get back into our content for module 1?
No questions.
Okay, so our topic in the first module is basically to
Actually, I got a quick question.
Yes, go ahead.
So there's actually this brand new website that just came out. Would it be okay if I did my little summary on that?
As long as it has to do with some aspect of integrated solution development or software engineering or team, developing software in a team, the core idea is about software engineering. If you have any doubts, send me a link and I'll have a look at it. Okay?
Okay.
So in our last class, we were explaining that there were a lot of finer points that kind of hang up a software engineering team. There's a broader scope, and there's also a scale. When you have an integrated solution you're developing in a team environment, you're talking about doing it for a large organization. So you could, in theory, develop a solution in your team that allows for UVI alumni to collaborate or to share events in a social network environment, right? And that's just one idea of how broad the scope can be. Usually you have platform issues, support issues, distribution. This is something we talked about The design triangle, does anyone remember the design triangle? From previous classes? Uh, Anybody remember operating systems? We talked about, whoop. Let's rotate this. Can everyone see this?
Yeah, yeah.
So along the way in the variety of courses that we've had together, at one point we talk about design interests. And we've already said that there were project interests in play. For example, if it's good and it's fast, it won't be what? Does anybody remember that? If it's good and fast, it won't be what?
It's not going to be cheap.
It's not going to be cheap. Thank you. If it's quick, if you pull it together fast in a short period of time, and it's really good in terms of the features and how it works and how many users it serves, it will not be cheap, right? So these are aspects of framing the project with the people you are hired to serve as software engineers. Another aspect of software engineering that is, it's kind of like assumed that everybody knows about this in industry. When you sit down and you start working requirements engineering, and that's this part of our course, requirements engineering. And once again, the purpose of our module is to give you like a view from 50,000 feet. What are the big points before we get into the actual detail? When you're defining requirements with the users who are hiring you to develop an integrated solution, there's a bit of combat that ensues, and it's classic. It's a timeless principle, and it's kind of like the 80-20 rule. We'll get into that in a minute. I call this the design triangle, and you have three primary criteria for development of any user solution, from operating system GUIs to full scale, like Blackboard, entire universities run off of this, right? When you design this in terms of the solution, it can be chock full of features. Your users can be giddy with the idea that you are going to create a custom solution instead of buying one off the shelf. So what am I saying? Instead of buying something off the shelf, like a solution that's framed and architected using Microsoft Exchange, Microsoft SQL Server, and the Office 365 suite. You can basically build applications very quickly that way, right? And you're using commercial off-the-shelf components that you can reuse over and over again and integrate with your enterprise solution. If you get to the place where the people who are hiring you don't want to do that because they don't have deep pockets, they can't spend all that money, but they realize that you're capable of developing anything. A lot of them will ask for many, many, many features. But as you start to arrange those features and how those features are accessed, how in the graphical user environment, there could be cascading menus with pop-ups. There could be, and I'm just using this as an example, You could have, and let's just use Word as an example. Look at all of the different features that you can tap, and the way the graphical user interface is devised over decades to cram so much stuff in here. And when you get to the developer ribbon, unless your Word user is familiar with things like, okay, mail merge, where you're tying in a database so that addresses are automatically populated in a form letter, or coding elements like checkboxes or fields, text fields, combo fields, drop downs, and this kind of thing, right? Whoa, that's a lot of stuff, which means in layman's terms, if your big focus is features, and that's where all of your users are, you won't have something that's easy to use. It won't be simple for the average tech user to engage. And what am I saying? There's a trade-off. So in terms of your solution development, you always need to keep this in mind. Just like scope creep. Does anyone remember the reference to scope creep last week? Something about that? The users want something and they need something, and wants and needs are two different things. What your customers need, and then what they come up with that they express as wants later in the development process, those are two different animals. You started out developing an integrated solution, and there were everybody agreed to a certain baseline of features. And then as the project evolved, the users said, oh, but that's not how we want this. We really have to add these extra things in there. So the size of the project and the number of features you have to build into it keep growing and growing and growing. Now, add to that dynamic the fact that the more features you have, that dozens, even hundreds of features built in here, it's a pretty daunting thing. And so Mac users are a great example. The world of Apple and their user interfaces and their apps are typically designed to be very quick and easy to orient, right, for the average person. Ease of use is their primary design criteria. It's not having 57 features. It's not having an app that looks like the cockpit of a 747. By the time you look at all the bells, all the dials, all the knobs, it's like, whoa, I'm sitting a commercial airliner, right? So you have all these features. If you're from the side of the tech universe where Apple is your favorite, ease of use as a design criteria is actually more important than features. And there's a piece of this puzzle right here that is a great segue to review the 80-20 rule. The 80-20 rule is something that works in combination with the design triangle. The 80-20 rule is, again, a time-honored principle of how your design criteria can be structured. What scientists have discovered is that 20% of the resources available to any user for any endeavor. I'm not just talking about using software applications. Let's use your toolbox. Does everybody here have a toolbox at their home? Anyone?
Yeah, I got a toolbox at home.
Or if you don't, or if it isn't in your home, do you have a toolbox in the trunk of your car? Or if you don't, do you have grandparents or relatives that have a toolbox? Right, everybody with me?
Yeah.
Yeah, so let's talk about tools and just home improvement. I'm not talking software or tech now, just anything human. How you organize your desk, how you organize your bedroom, how you organize your car. See, 20% of the resources are actually engaged about 80% of the time. The 80-20 rule means 80% of the time, just 20% of the available resources and features are actually utilized. Holy buckets. If that's true, and that's actually a pattern, and it's a repeatable, verifiable aspect of human nature and the universe, it's like a law of gravity, right? What does that mean when you're looking at the design triangle? When you're looking at the design triangle, how do you put fewer things to make it simple, to keep it simple for a user so they don't run screaming from the room? Because they're like, I need a pilot's license to operate your software. I just can't use this. It's a nice solution, but oh, can we put our old solution back? That happens. It's not a pretty thing. What do? You identify the 20% of the features and resources that you know will be used 80% of the time, and you incorporate that in this concept of how to apply weight to your given scenario. And the only people that can do that are your customers. The only people that can do that is your team working with your customers. There is no formula. But you have to drive the train, and you have to have this discussion in an intelligent fashion with your customers. You got to say, okay, I'm going to give you everything you want that you can't find in an off-the-shelf solution. But I have to know what's the most important stuff you need, and whether or not using it with ease is actually a more important criteria than the number of features on your screen. You have to have that conversation with your customers. And if you don't get that in writing, you have failed in that stage or aspect of software engineering known as requirements engineering. Everybody with me?
Yeah.
Now, this is something we introduced in Intro to Cybersecurity, and then later in System Security, and at times in operating systems. We said that if something is easy to use and it has a dearth of features, that means that it's real easy for users to access and get a hold of and to tap into, which means it's also easier for hackers to use and navigate around. When you make it easier for users, you're also making it easier for who? The malicious adversary. And why does that matter? Well, maybe the custom solution you're building is for a healthcare organization. And if you don't protect healthcare information, electronic medical records, you go to jail. You don't get fines, you go to jail. There is a mandatory 5-year jail sentence and $50,000 fine for every breach of security with regard to healthcare, electronic healthcare records. Did you know this? It's called HIPAA. It is a federal law that says you better protect your medical records. So what happens with the design dynamic? Well, ease of use is not as important as a criteria. The number of features isn't as important. When those two together are like the dynamic duo, they kind of suck all the air out of the room, and all of the design effort is over in this part of the software engineering universe, which means that security is likely to suffer. Well, you have lots of features, which means you have a massive footprint for an application. And whenever you have a massive footprint of all those features, there's all the more exposure for things that can be buggy, things that are, well, okay, the coding wasn't entirely safe, and there are ways that hackers can poke more holes into it. The fact that it's easy to use means that hackers who don't really understand a whole lot about your process can learn very quickly. So what am I saying? If your customer is more concerned with security, a government agency, a banking institution. But ladies and gentlemen, I went to a local bank a couple of years ago, just 2 years ago, and I was closing out an account, and I saw somebody running Windows 7, as in Windows 7, like nearly what, 16 years old and no longer supported, and there are no more updates, right? And while I was pulling out my money and closing my account, the clerk said, "Oh, hey, if you're leaving us because you don't have convenient access to your bank account, we have new online stuff." And I was looking past the counter at the screen where they were sitting ducks. I'm not going to tell you which bank it was, but this is a true story, right? What is part of your solution? Well, the operating system, it runs on top of, right? So what are we saying? Software as a service doesn't really concern itself with those dynamics. So you're just taking for granted that the platform and the operating system, the hardware and the operating system layers, the infrastructure as a service and the platform as a service, those pieces of the cloud resource environment, it's a given that those are taken care of and somebody else is minding the fort. And as you all know, networking and operating systems are two huge exposures that can be an issue. So what am I saying? Depending on your security interests, you may be less interested in an agile environment, a latest, greatest adaptive development method that creates cool apps in the cloud. If you're more concerned with security because of government requirements, right? The important thing to understand is that whichever criteria is the most important, it tends to diminish the other design criteria in the mix. Because if you're going to make something that's really secure, it's not going to be really easy to use and access. I mean, can you get a working screen? You got to go through 3 different authentication and login requirements, right? That's not easy to use for a lot of users, but it's secure. What about the features? I don't have a huge footprint. I don't have 80% of the features in my system I never use. And why? Because hackers love to tap into things you don't use. It's a great landscape to hide in. You don't think about fixing the bugs in features you don't use. 80/20 will bite you in the backside. It will be, well, let's just put it this way. I have personally presided over the termination of software engineering professionals because they didn't get this. And I'm speaking from personal experience. You have to be able to talk about these basic things. Now, this is stuff that you won't necessarily find plainly stated in each of your textbooks, but you'll see hints about it. And then you find out in the workplace, oh, where's the rest of the material I need to know? So this is kind of a value-added industry kind of thing that you get once you're in the workplace and you've been developing solutions for a while. And what you'll find is that a lot of workplace environments now don't choose one software engineering model or another. They choose the one that matters for each customer. They're fluid, they're flexible, and they consider the design criteria that matters most to drive their design process and their requirements engineering as a critical phase of the solution development. Okay? Any questions so far about the design triangle and what that 80/20 rule means? You will see, and this is important to mention, you will see other references to the 80/20 law under the guise of other research or other disciplines. What am I talking about? Let's take a quick moment to drive this. Is everybody with me so far?
I am.
Okay. Can somebody remind me at like 3:28 that we're going to take a short break for a couple minutes? Because I promised we wouldn't just go like 2 hours nonstop.
Will do.
The 80-20 rule can often be, you can often ferret out the 80-20 rule stated in a different manner when you're talking about hardware development. So there are often many causes for the 80-20 rule repeats in a variety of other phenomenon, not just resource utilization or feature utilization. The 80-20 rule is often a principle that plays out in other contexts. And when you're talking about hardware development, right? Another one is Zipf's law. ZIPF, the Zipf principle of least effort. What's that about? Oh, it means that what you need the most is closest in reach. So you get to it with the least effort. Does that sound a little familiar? Oh, it has to do with efficiency engineering, and the efficiency engineers came up with this. So there's science. There is real science behind this. Hello? Yeah, I'm not just pulling something out of my backside, right? But it's called ZIP, and that would be like the efficiency engineering world yeah, so efficiency engineers are intentional and ruthless about how to decrease the amount of work, least amount of work to accomplish the greatest outcome, right? And if you read, it's talking about efficiency with the least effort. So there are echoes of 80-20 all over the place. They just come in different flavors and different notices. So that's worth stating, because if we put everything you'll need for a course within easy reach, you'll probably be more satisfied. What am I saying? Have you ever noticed how I go to a lot of trouble to put stuff within easy reach that you really need? Yeah, there's a reason for that. I'm just saying, you know, I believe in this enough to live by it. Okay. Any questions about design triangle and other names for the 80-20 rule?
None for me.
Now, we did talk about COTS, commercial off-the-shelf solutions. And just 15, 20 years ago, there was a website called Programmer's Paradise. And you could basically go there and you'd say, okay, I need a GUI. Give me a GUI. And you'd pay for a GUI with certain features. Oh, I need a database backend with import, export data functions. Oh, I need to do it in Java, in Visual Basic, I need it in a web environment. You could basically just buy it off the shelf, pre-built. Well, there's a trade-off. When you're using those resources, if something doesn't work, it's like you didn't build it, so how do you fix it? And the answer is you don't. So if you click this link, Code Canyon, these resources for coders in the previous generation. By the way, you guys aren't millennials, right? Millennials are older than you are. Are you Gen Z, or what's the latest? Anyone? Do you know what? I'm not going to ask your ages. I know you're like early to mid 20s. So, well, that's another question for another time. When my generation started to pass the baton to millennials and the younger generation, basically these things kind of faded out because those development resources changed, but the concept is still valid. Nowadays, they're open source, and there's something called, I don't know, Stack Exchange, GitHub. Why am I mentioning that? Stack Exchange and GitHub may not be commercial, but they have ready-made components, coding modules, right? And the problem is that if they're pre-built, you have to be careful if you're using those, if you decide for your enterprise solution that you're going to use stuff like that, and you're going to copy and paste crap out of GitHub. Let me say that again. I will not be impressed with you in this course if what I see is a bunch of stuff I can Google and there it is in GitHub, and I ask you what it does and you can't explain anything about it. That's going to be a problem. Okay. Now, does that mean you can't use stuff? No, some resources in GitHub and in Stack Exchange are exceptionally well structured and supported, right? So it all depends. You just got to be careful. There's a trade-off when you use easy stuff, because later on, there are problems that aren't so easy. Just saying. Let's take a short break. I want to take a 2-minute pause. I'm going to hit the pause button and pause the recording. So the world of software engineering can be divided into two distinctly separate halves. The traditional methods, or legacy. The word legacy means traditional or old school. These are original grandfather kinds of models that teams used to collaborate in developing an integrated solution. So each developer had their own components and they figured out how to bolt them together. And that's what these software engineering models were about. There was a revolution. It was called the Agile. It was kicked off by something called the Agile Manifesto, the adaptive models. There was an awakening of sorts among software engineers, and they suddenly decided it was kind of like a collective awareness or collective consciousness, almost like the Force in Star Wars. Right? There's a lot of really romantic notions about how Agile kicked off and how it was, everybody was throwing off their shackles, so to speak, to do this adaptive development model, or to implement new ways of working together as programmers, right? The rest of our time is going to be talking about legacy models, but I want you to understand when we get to module 2, we're focusing exclusively on each of the models. You have to be basically familiar with the different models by name, but you don't have to you don't have to recite an exhaustive amount of content about each in this module. You do need to know which ones are which, okay? And that's where we are now. So we're going to, the traditional or legacy models are often referred to as the P&D, or planning and document models. So they would plan to build a huge integrated, multifaceted, enterprise-wide solution that everybody could use. The bookkeepers could use it. The human resources personnel people could use it. The sales and marketing team could use it. The administrative folks, the financial folks, the technology and database developers, everybody could get in on the act, right? So everybody uses this one application. Wow, what happens if it goes kaput? Well, if you're dependent on your organizational process, that can be an issue, right? So one of the things that's a strength, one aspect of traditional models upon which they depend heavily, is that they require a strong manager. Now, this I got to repeat over and over again. A strong manager means you have somebody in charge and they help make decisions and frame the development process, and they make critical judgments when there are, I don't know, problems to solve, right? It requires a strong manager. If you have a group of programmers together and they're like islands unto themselves and they're all autonomous, and nobody would really lead anybody, but they'd work together. You're looking at an adaptive agile model. A traditional model for a group like that would be suicide. And I know I'm getting dramatic here, but wow, I have seen some really bad things happen. If you're going to do traditional approaches to create an integrated enterprise solution, and there are so many different components, and each of those components are developed by different programmers, different software engineers, and then they piece all those things together. It's like a factory where the SUV is being built, and well, there's a group that does the transmission, there's a group that does the engine, there's a group that does the body and the chassis, there's a group that does, you know, the user, like the passenger luxury things that, you know, people use, somebody that does the brakes, the AC, you get the point. Everybody does different things. When you have a finished product and one of those teams is weak, well, then you have the stuff of legends. Like certain models of car are notorious for bad transmissions, or this brand of car always has electrical problems. The same holds true in planning and development models. Now, if you have not yet clicked into the resource for your SAS, right? So we start, was it SAS book, right? Everybody see this table of contents? Right? One thing you want to do before too long, you want to go to the videos. Everybody? So I think we did mention this, and there is a reference to it somewhere else. See videos, chapter 1. You want to, oh, and by the way, here's all the stuff that's, I mean, they have videos to help support each of the chapters in the textbook. So as you're using their model to develop an integrated solution, I mean, it's like they have their own custom built YouTube channel, right? Except it's not YouTube. I want you to get into chapter 1, and I very much want you to go 1 through 3. This is actually listed in Blackboard. Has everyone seen that, right? In here? What does it say? Please review the first 4 videos in chapter 1, right? So what are we talking about? You click here. Oh, there it is, chapter 1, right? Yeah, you do that. Now, why am I mentioning this? Because it talks about some of those spectacular failures. And this is where we are right now. We're in the plan and document mode. And here is where he talks about some of the really bad things that have happened with the traditional model and what led to the revolution, right? But in any case, you will find the plan and document model in use all over the place. In particular, there is a development life cycle, kind of, well, SDLC, right? So waterfall, spiral, rational, unified process, these are big examples within waterfall. In module 2, you're going to find out that there are some really cool flavors of waterfall, right? The important thing to understand is that you need a strong manager. We've already talked about that. The other thing you got to understand is that there are 5 important stages that tend to repeat over and over and over again with each of those traditional approaches. One is requirements analysis and specification, which is kind of like requirements engineering. Where am I? Kind of like requirements engineering, okay? So actually that's really important. So we're treating it as a separate part of your team development, right? When you come together as a team and you declare that you're going to develop a solution as a project together with another student in this class, you are not coding alone. No one is coding alone. The first thing you're going to do is what? You're going to take a look at what's required. That kind of tracks with this stuff right here. We talk about this. So requirements analysis and specifications. Architectural design. So in that case, we're looking at back-end components. What do we need in the platform in order to deliver the features and functionality that we identify here? What's required underneath the hood? What foundation do we need in terms of platform, in terms of operating system, in terms of database? RDBMS. Does the acronym RDBMS sound familiar to each of you at this point? Have you all heard of the acronym RDBMS?
Sound familiar.
Yeah, it sounds familiar as well.
Okay, here's a hint. Did you have a class called CSC 245 database? It's Relational Database Management System, or if you had 239, we talked about RDBMS. They're relational database management systems, yeah. So you may have a specific database that you may have a backend database that needs to be replicated across sites because an enterprise can be very large. An enterprise can be global. Here is one example of an application that was recently developed for the Department of Defense. Specifically, it was the US Army. The United States Army has over 1 million systems in its Active Directory domain. Let me repeat that. There are over 1 million computing systems that are interactive and part of the army.mil domain. Not army.gov, army.mil domain. Okay, so you might have architectural needs like that have to scale. Implementation and integration are that's where the rubber meets the road. So you design the architecture, then you develop the solution, implement it, and integrate it. Then you have to what? Validate your outcomes. You have to verify operation. You have to run. Oftentimes you run in parallel with the existing system. So if your solution is designed to replace an outdated integrated enterprise solution, or it's designed to replace a piecemeal combination of separate and disconnected applications, which is sometimes the case, then a lot of companies want you to operate what they have now while you're operating the new system so they can compare results and say, okay, are we getting the same results? Is this reliable? Is it working? The last stage is maintenance. You have support, you have bugs, you have things that come up, you have updates in the operating system underneath that throw it off guard, you have updates in the architectural design, meaning there's new versions of the database engine on the back side, right? If you've had web development, CSC 310, there's a back end that's a database and a front end that's a user on the web, right? User interface on the web. So maintaining this thing is the last and final stage in the earliest P&D models. Now in subsequent models, in the later models, some things changed, right? Any questions about the basics and the original models? So once the results of a new system can be verified, then cut over to the new software solution allows the old system to be discontinued. Cutover is a huge, when they cut over, there's usually a lot of unexpected complications, but that's like the last part of it, and you can consider cutover to be the start of the maintenance phase. Common planning gap is failing to account for the added cost of overhead for operating systems or for continued maintenance, right? All that kind of stuff. So that's one thing that you want to consider when you're pitching your solution to a customer. You want to say, well, after we're done, we're not really done. Because We have to continue to support. You have to continue to pay for software licenses on an annual basis, right? We have to distribute the new version of the solution so that now you're going with a user-centered license model, which means that only 30 users simultaneously can use it. We don't care where they are. We just know that a max number of 30 people in this one department can use these features. Versus a computer or system-oriented model for licensing, where it's like, okay, you can put it on 30 screens. We don't care how many users are on and off those screens. Right? Those are things that, you know, require some thought. Or you just don't keep getting paid and, you know, hey, it was nice while it lasted, but you couldn't make a living being a software engineer. We've actually seen that happen, right? Now, for the first stage, requirements analysis, it is critical that requirements are clear, easy to understand, unambiguous, and consistent, so that they are not easily misunderstood or misconstrued based on condition or context. You don't want to come back next month and your users are all bumfuzzled because it's on a different screen. Okay? You do want to engage your stakeholders, meaning your customers, to prioritize who's doing what and where the priorities are. And of course, we get back to verify, verify, verify. One approach to managing requirements analysis, which is part of requirements engineering, we're going to deep dive into here. Some models refer to that as requirements analysis. When you're talking about that, it's called the Moscow method. So what you do is you look at the features that must be included, then you look at the features that should be included, then you look at the features that could be included if there are enough resources, and you identify, we're not doing this. We are not going to have a feature that involves online payment because we don't want to protect credit card numbers. We're not doing that, right? So you may decide there are some things that are not part of it. That's called the Moscow method, and it's explicitly associated with requirements analysis, which is which phase? The first phase, right? Planning and document models or legacy models are known for being wasteful and over budget, in part because the customer who was excluded from much of the development process often concludes the first version was not what they needed. They say, oh, well, yeah, we helped you with the criteria for the solution, but that's not how we expected it would look on the screen. That's not, we don't need it. No, it doesn't. It has to work differently, right? It's been said that most customers don't really know or can't articulate or visualize precisely what they want until they have something in front of them. And then, unfortunately, with traditional methods, old school methods, you can flip a coin. Half the time, your customers are going to say, yeah, I get that that meets the specifications, but that's not what we want, right? So then they learn what they really want in version 2, right? In fact, version 2 is kind of a legendary, don't buy a version 1 of anything, right? They also learn how best to create what the customer wants after the first attempt. So this is true for both software engineers and for the customers. That's when the software engineers go back to the drawing board. They're ticked at this point, but at least they're not completely like disavowed. Nobody's fired them, right? Okay, we have too much money in this, so we have to get it right. Which means you spend more money and it takes longer. So it's wasteful and over budget, right? Planning and development models are not well suited for environments that must accommodate significant change often. If you were doing things that require like rapid development, gaming would be a good example of this, right? you're not going to want to use a traditional model for software engineering. If you're developing for, I don't know, PlayStation, Xbox, right? Anyone ever heard of Angry Birds? Angry
Yeah.
Birds? Yeah, the little cute little app. Okay, so here's one of the things that changed all this. When the internet came about and cloud-based technology became popular, a lot of the traditional models that people depended on to develop solutions went out the window. They're like, you know what? I can do this in the cloud. I can do this for less, and we can adapt fast. That was one of the things that set the stage for the advent of our agile and adaptive models. Now, this is really important. Something that takes 3 times longer and costs 3 times more simply won't work well in many new environments. Internet opportunities evaporate without adaptive and agile methods. So this is one of the caveats or limitations, one of the constraints or restrictions of traditional planning and development P&D models, right? Now, despite all of their detractors, they are still preferred when, here we go, inexperienced programmers are involved. Okay? You do not have access to a strong team manager. Hello, that's something that could be listed here. Strict specifications are required by regulation. So the US government says, I don't care what you're doing, HIPAA, you have electronic health records, you have to do this. Documentation is expected as a part of the culture. What does the D stand for? Documentation. When there are changes to the software, it is documented, right? If the system is large or complex, has a long lifespan, a lot of government solutions are developed with P&D. In fact, a lot of them use kind of like a hybrid mode of P&D called SDLC, Software Development Lifecycle. We'll talk about that more. And you can implement an SDLC concept where it's really more like a P&D model. Or if you're innovative and you want to mix it up and do a hybrid, you can turn SDLC on its side and integrate some agile methods. One thing you're going to notice is that some development solution providers kind of mix it up. It all depends on the need and the interest. But when it comes to traditional models of developing solutions, the system is large. The programming tools are difficult or lack quality. So why is a planning and development model of solution engineering an ideal thing where the programming tools are difficult or lack quality? Because you're documenting, oh my gosh, the programming tool isn't working, and oh my gosh, we don't have quality. So you are able to document the limitations. And so when people want to kick you to the curb, fire your team, they don't want to use you anymore. You can go back and you can say, well, this isn't us. It has to do with the tools. You insisted on using old development tools. If your development team is geographically separated, what am I saying? Adaptive, agile, new, latest, greatest software engineering methods. The team is like, I don't know, they're burning the midnight oil, they're having a pizza party, right? They do something called a scrum, which relates to rugby. It's kind of like everybody cramming for final exams as an undergrad in the study lounge. That kind of thing is good for agile and adaptive teams where there's who is the leader in charge is less important than who's covering which functions, right? When you don't have that and you have programmers in different parts of the world and they have to deliver certain things on time, that's a P&D model. If your team is geographically separated, you are constrained to use the old school model, even though well, you're not going to be as adaptive, right? If your customers are not available during the development period, when you use adaptive agile methods, your customers have to be involved all through the process. They're part of the development process. Your customers are within arm's reach. You come up with a new idea for the user interface. You show it to the customer right there. That's not a planning and documentation model because those are old school. You're developing something for the Department of Defense. The people who use it are not available. They're on the battlefield, or they're in the Ukraine, or they're near the Ukraine. There are cases where planning and development models are superior to adaptive and innovative models simply because you don't have access to the customers while you are working the earlier phases. So if you get to the place where you're working the implementation and integration, you're hammering out the architectural back end, right? You're engineering or architecting the back end, the big databases, the repository for all the information that the GUI will draw from to populate to the screen. That kind of stuff, when you implement and integrate, all of that kind of stuff, you can't, right? If your customers aren't there where they can take a look at what you got, you don't need to be working with an adaptive and innovative model. You still want to use the planning and development model. So even though we say, oh, yeah, this is the original, it's a legacy, it's not as effective. Well, it's not effective depending on the circumstance. Are there any questions about traditional legacy models?
No questions.
Okay. Can we take a short 30-second stretch break to see how far we can get with adaptive innovative models? So now we're going to be doing this. Just a broad brush overview of the general concepts of the adaptive models. That'd be really cool. I think it'd be really cool if we got that far. I don't know. I'm just saying. We're cooking with gas here. Okay. 30 seconds. I'll just pause, get up and stretch. So as we're working through the student learning modules, we've just completed our review, right, of the first student learning objectives. Hold up. We look at the student learning outcomes. Now, we're going to cover the Mythical Man Month at another time, although there's reference to that in the videos, right? Contrast the primary distinctions between the two main types of SE models in use today. That's what we're doing, okay? Reciting timeless axiom for project management that applied to SE models. That's the, if it's fast and it's good, it won't be cheap. If it's fast and it's cheap, it won't be what? If it's fast and cheap, it won't be what? Anybody?
Good.
Won't be good. Won't be good. It'll get the job done, but it'll be crude, right? Okay. So these things that we've already talked about, we've covered most of this here, right? We'll get into that last part. All right, moving right along. Traditional or planning and documentation models, the adaptive, there was a revolt of sorts. A lot of traditional coders got fed up having every aspect of their project controlled. They could not be creative. They could not work in teams. They could not turn things on its side. In particular, there are some companies in Silicon Valley where they felt like they were in a straitjacket. So when you think about the latest, greatest, most adaptive companies that are developing these really radical applications. I don't know. I'm thinking of like, what's everybody's favorite platform now? Is it Facebook still? Are all of you Facebook fans, or are you on another platform right now? Come on, fess up.
Yeah, Instagram as well.
I'm sorry, what?
You like social media?
Yeah, in terms of social media, what's your favorite platform now? Is it still Facebook, or has something else kind of emerged?
I would say either Instagram or TikTok for me.
Oh yeah, thank you. Thank you so much for validating that. Yeah. You know what happened when I went home for Christmas? I was called grandpa because I still looked at Facebook and I was told I don't I don't got it anymore. That's what I was told. I was informed by my children while I was bouncing my grandchildren on my knee that I needed to get with it. See, TikTok, there's a lot of innovative and agile. The term agile means nimble or flexible or adaptable, right? So there was a revolt, a bunch of highly controlled, micromanaged, and ineffective work environments created a huge groundswell among professional developers. And in one voice, they all just kind of came together at a ski lodge in Colorado. And they wrote something called the Agile Manifesto. Now, you're going to see links to this in our module 3. We're going to do a deep dive on the Agile Manifesto and what that really means. But it was kind of like a declaration of independence. No more micro-controlled in my scalp, telling me everything I got to do. And it takes forever to get anything done, right? Everybody just threw off the shackles and they decided, you know what? We don't need this kind of structure anymore. This is like being in high school, and we should be in an undergraduate research environment where we're just cooking up cool stuff in the lab. Screw that old cookbook, follow the textbook laboratory, the laboratory guide for chemistry. Oh, I mixed the baking soda with the vinegar and it bubbles, and now I've released carbon dioxide gas. Does anybody know what I'm talking about? I'm talking about scientific method where you repeat canned experiments and it's like really following a cookbook. You do things that you know are going to happen. I mean, you walk through the steps in the lab and what? We all know what happens, right? How would you like to spend the rest of your life doing that? Well, a lot of software engineers said, screw that. I don't want to do that. It was a cultural turning point, and this is significant because they developed some new models where now all of a sudden a small team can make some hay. A small team can pave some road. A small team can, I don't know, build a TikTok in 3 months flat, or a Twitter in 6 months flat. Something that changes the world. Don't you know that adaptive and innovative models for software engineering are in use with, I don't know, the guy called Elon Musk? Has anyone ever heard of Elon Musk? Anyone? Anyone?
Oh yeah.
Yeah. Yeah. Elon's talking about he wants to buy something. I mean, the latest rumor is, oh, he's going to buy Google or something like that. Wouldn't that be a trip, huh? Elon Musk in charge of Google? Yeah. I hope that never happens. I mean, I don't know. Anyway, I don't want to talk about that. New and improved adaptive models such as Agile, XP. XP stands for Extreme Programming. Repite usted, por favor. XP, Extreme Programming. Extreme Programming? Oh, can I at least get an amen? Some people call it pair programming. Have you heard of pair programming before? Somebody's coding and somebody's writing shotgun. Yeah. Then there's this cool adaptation of Agile called Scrum, slightly different model. It's like they have pizza box sessions. We'll learn more about this, but basically, you get to create something in much shorter cycles in a few weeks or months, as opposed to years. And then you get it in front of the users, and the users are like, yeah, this is what we were missing. Now I get to see what we're doing. Oh, we're almost finished. When can I sign the contract with you guys? Right. They turn the industry inside out. This often causes a great deal of confusion, right? These adaptive models are not the same as a tool suite of development utilities that are integrated into a development environment, IDE, and they're promoted as rapid application development. Oh, to make matters worse, there's actually an adaptive model called James Martin RAD. Okay. And his use of the term RAD is a similar acronym, but it's an authentic adaptive model. When you see a reference to RAD and it's talking about an IDE, that is not a software engineering model. That is a set of programmer tools for rapid development. Like, here it is in the box. Here's an email interface, bolted on. Now you have email features in your application, right? That's RAD. That is not software engineering. That is not an agile method of software engineering. That is this all over again, version 2.0. I'm talking about clearinghouses with pre-built code, whether it's open source or commercial, you buy it. That's what I'm talking about. So RAD is a little different. RAD is, so you have these IDEs that say, oh, for rapid application development, here's what we do. And, oh, and by the way, they can be used either in planning and development contexts, or they can be used in adaptive software engineering models. But when you hear the term RAD, just remember that James Martin RAD is the real deal, and it is one of the methods for adaptive software engineering. It's a new style method, and it's a variant of Agile. When Agile was first introduced, many in the industry were very critical, especially those who promoted and developed lucrative SE models of their own. For example, IBM purchased Rational Unified Process. It was a pre-built framework for huge integrated solution development. Here's the problem. RUP became a cash cow for IBM. What we're saying is that anybody who liked working with IBM suddenly started getting all sorts of marketing pitches to adopt RUP. And the simple truth is, if you're going to do RUP, it is agile, but it's based on a titan of the planning and document world, IBM. And when the adaptive agile models started taking over everything, IBM was like, what do we do? What do we do? I know, we'll develop our own and we'll market it. And yeah, we'll still be in charge of everybody's development. It is tightly aligned with business process. The acronym IBM literally stands for, does anyone know what IBM stands for? International, what's the B for? Business machines. They're talking about, well, first calculators, computers, right? And then mainframes, and then PCs, international business machines. That's what IBM stands for. By the way, cute side note, both IBM and GE make more money now as corporations with their money than they do with their original product line. I just thought I would mention that. And while IBM was so affluent, in the planning and documentation era. They had a research and development team in Raleigh-Durham, North Carolina. It was called Research Triangle Park, RTP. Research Triangle Park, RTP. There's an IBM research center there. IBM has a vault of new technology. They own 25,000 patents for new developments they have yet to release. They haven't even marketed the products. 25,000 patents for new tech. Yeah. Well, in this case, what they did was they purchased Rupp, and they said, okay, we got to move fast. How do we get on the train so they don't leave us behind? They bought Rupp. So Rupp was tightly aligned with business process, which is why IBM liked it, because what? Business is part of their name. So when the leadership of an organization is driven by those who are trained in an MBA program and finance degree programs, Agile would seem like heresy. It would seem like, no. See, admin types, business administration. Does everybody know what the acronym MBA stands for? MBA? A Master's of Business Administration. It's a degree. Oh, on a separate note, can anybody tell me what OG means? I was watching a Netflix thing and they were talking about this person is the OG of his discipline. Slang. That's actually pretty old, right? Isn't OG original gangster or something? Gangsta. IBM was the OG. I mean, for lack of a better description, right? Now, is that like a old term by now? Is there another term that means something else that's more relevant or hip? Somebody please talk to me. We're near the end of our session. We're gonna quit like 4:15, 4:20 at the latest.
I don't think there's a new term.
There isn't. So OG is still relevant.
So yeah.
Okay. So if I make that reference, I probably look silly saying it, but anyway, Master of Business Administration and Finance degree programs, Agile was like, oh, the business world's going to be upset because, I don't know, our legacy programming company from way back, you know, oh, they have planning and traditional methods, right? Planning and documentation, traditional methods. After 10 years of practice, many leading companies must develop lots and lots and lots of mission critical software, Google, Amazon, Microsoft, and they're now using agile and adaptive variants to promote and preserve what is known as competitive advantage and operational resilience. To that end, container development is like a new latest, greatest concept in solution development. Has anyone ever heard of container development? Docker, Kubernetes.
I have.
Right. So basically, you build the application, it lives and operates in the container, and you don't care what's running it. It can run in Amazon Web Services, which, as I understand, should perk up some ears in this class, right? Aren't some of you AWS aficionados at this point?
Yeah.
Okay. Yeah. So you can containerize apps. I mean, you can develop in the cloud too, right? In general, adaptive SE models are well suited for environments that change rapidly. Cloud computing and software as a service are two examples of computing environments where Agile and its offspring can truly shine. The reverse of conditions that warrant use of a planning and documentation software engineering model are conditions that merit consideration for the use of adaptive models. What are we saying? If you have experienced programmers who are involved with the project and they're comfortable in their own skin, you don't have to have somebody guiding them. They're not inexperienced programmers. They are each champions of their own skill set in their own right. And everybody respects them. It's like, who is your database guru? Oh, that's Barb over here. She is awesome with database backend. But don't ask her to deal with data input and output when it comes to like data entry. That's a different person, right? So strict specifications are not required by regulation. Documentation is not a dominant part of the culture. The system features and functions are plain with straightforward outcomes. That's a biggie. If you have an integrated solution where it's like, okay, we're going to keep this simple. What am I thinking of? This is a PayMe app that makes it real easy to put cash in someone's hand, and it's an offshoot or its parent company is PayPal. What am I thinking of? Hello?
Yeah, we're here.
Don't you have it on your, you might have it on your phone.
Which feature we talking about? Kind of cut out there.
I mean, I'm not talking about Google Wallet. There's an app, and all you got to do is, oh, why don't I just draw a blank?
Talking about Google
Venmo,
Pay?
Venmo,
Venmo.
Venmo. Has anyone ever heard of Venmo?
Yeah, I heard of it.
Yeah.
Yeah. Did you know that if you set up a Venmo account, I can beam you a $5, $10, $100 bill right now? It goes straight in there and doesn't cost you anything, right? That is a great example of something where the system features and functions are so simple and it's so straightforward. Now, I don't want to pull up my Venmo screen because if my password is saved, it's going to be right there, and then my business is going to be in front of everybody. But the system features and functions are plain with a straightforward outcome, right? High quality programming tools and environments are available. So when can you do adaptive, agile? Oh, when you don't have your hands full with a buggy programming development environment, integrated development environment. The development team members are local and remain available for each other. You must remain available for each other if you choose to use one of these adaptive models to develop your integrated solution. What am I saying? You're going to choose one of these models to collaborate as a team. So it's important you learn about them because you're going to be stuck with them the rest of the semester. Customers are available and committed to review the prototypes, right? So when your customers can be involved all along the way, you want to use adaptive. All right, we're going to stop right there. And we'll pick up with the remaining material on Thursday. And then you'll be in a good place to finish off. You know what? I'm going to hold off on the solution. I'm going to post the solution on our second module. We'll give you some time to work a solution. Most of your solutions are actually in the team context, right? Beginning with project initiation around midterms. So we'll take a break from the normal routine. However, we will have an assessment of module material, beginning with this stuff right here on page 4, right? When we start talking about object-oriented programming and how that kind of plays out, there's an element of that that's interesting to investigate. That's what we'll cover on Thursday. Any questions before we clear the session?
None for me.
So, what did we cover today? We contrasted the primary distinctions between the two main types of SE models. And yeah, we'll circle back and mop up. We also talked about the design triangle and the 80-20 rule. And the 5 stages of the all SE models, regardless of which type they are, they all cover those 5 stages, right? So those elements of those 5 stages are present whether you're working adaptive or you're working plan and documentation. The 5 we covered, those are the student learning objectives we covered today.